And okay, today we are going to move on to something extremely similar to what we just did. Remembering what we just did was working with stacks. And today we're going to move on to something called queues. And just a quick refresher up here in the blue box. It's nice. I already have it written down. You can be writing it down as we go. But when I did a stack, the last one in was the first one out. So they were both at the same location. Now I just need to remember in the array, where was I putting them? In the linked list, where was I putting them? And in the array, I was pushing at the
And
end of the array, and I was popping the same spot because that last one in was the first one out. And then for the link list, it worked really well for us to be pushing at the beginning and then popping at the beginning, getting that same one both times. I think we said this quite a few times now. Hopefully, we can get it straightened out. Again, stacks is LIFO. Today, we're going to talk about queues, which are FIFO, and they're going to look a little bit different. There's a reason why we did stacks first. It was a little easier, but now we're going to do queues, and you'll see as we go, it's going to get a little harder. Over here, we were pushing and popping. Today, the common terminology is NQ and DQ. Enter the queue, delete from the queue. Isn't that clever? Yeah. Okay. So let's talk about it in terms of an array. I'm dealing with an array. How would I do this? Well, the first one in is the first one out. So wherever I add is going to be the opposite of where I delete. Up here, they were the same place. This is going to be opposite. Well, let's start by thinking of this as maybe a grocery store. Here's the cash register. It's one of those old-fashioned ones that's sitting on a table, and the first person walks up, first one in, and then there's two more people walk up right behind them, and they enter this queue. They're in a store over in England, and they enter the queue. And when you enter the queue, you add at the end. Right? We're going to keep adding at the end. Very bad, poor um, hangman there. And we're going to remove from the front of the queue. Okay, they're going to put all your groceries in a sack instead of a bag. So yeah, we could make this talk with a British accent day, or I'd rather do a pirate. Arr, just say Argonaut. Okay, so this guy was the first one in. He's going to be the first one out. Again, I'm going to keep looking up here and keep that in mind as I get ready to do my array. Um, some okay, you got the idea of what's going on. We're going to be using the that array class kind of thing. We're going to use that linked list class kind of thing. We're going to be writing functions NQ and DQ to create a new class to be able to work with a queue. All right, so I'm going to start with an array of size 10. Size is important. We always know that we need to keep track of that. Some other things that we always had in the back of our minds was a function for is empty, is a function for is not empty again, but we're going to do the opposite, is full, which means we're going to need some sort of count. I didn't even start anything yet, really. And I'm now trained to do, wow, look at all the stuff I'm already trained to do. I know I'm gonna have functions is empty, is full. I'm gonna have a variable size. I'm gonna have some sort of variable count. I may need other stuff. I don't know. But let's work our way through it. So we had some variables, we had a couple of functions. We now know we're going to have a function called NQ and a function called DQ. I don't we might need more than that. Sure, there's going to be need for some sort of traversal. Print out all the names of the people in the queue or all of the letters of the people that are in the queue. All right, I'll do the first one. I am at array subscript 0, array subscript 7. I'm writing stuff down just in case because I know this one's harder. Um, I do apologize. My count is not 10. My count is 8. I need to go watch Sesame Street and talk to the count. 1 array element, 2 NQA. I got the first one. Boop, boop. One thing we wanted to stay away from when working with arrays was the ever popular shifting, shifting, circle, slash through it. We don't want to have to shift if we don't have to shift. Where do you want me to stick the B?
It'd be element 1.
So you want to put this at element 1. What about C?
Element 2.
Yeah, okay. C, D, E, DQ. We're going to DQ. What are we getting rid of?
A first.
A first. Right. So we want to get rid of A and um going through this the first time. This is what I have left. Our thinking hats on. What do you want to do?
Got to shift everything back and remove from size.
Where would I add the next one? If I said NQF, where would you like to put it?
At the end.
At the end. Where, if I now said DQ again, what would we be getting rid of?
B.
B. Did we have to shift?
Could you keep a counter and keep the counter moving as you DQ and one as you NQ?
Keep a counter. You mean like a location counter?
Yeah.
Good idea. What's the rest of you think?
Something to keep track of where you are at the beginning of the queue as well as the end so that you don't have to shift.
If we had a variable called front and rear. Squeak, 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 squeak. I think that's what I'm being told. Start of all this, where would I put front?
0.
Mm, is there something in there?
No,
No.
Well,
Where
A's in
what's
there
that?
if we in QA.
Well, once we NQA, I think I'd like the front to be. Should we, and this is going to come up a couple of times throughout the rest of the course, have that as my initial yada 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 kind of thing?
Should we start front at -1? That way it can never actually enter the array if it's empty.
Yeah, yeah, and that's what's going to be recommended. The initial value for front to be -1 and the rear to be -1 kind of deal. Okay, if I NQA, what would the front become?
Zero.
0. What would the rear become?
Would it also be 0 or would it be 1?
It would also be 0. If I NQB, what would we have?
0 and 1.
So it looks like every time I NQ, I'm adding 1 to the rear. So right now I'm looking at A, B, and C. When I had is empty and I added 1, I had to change the front to 0 and the rear to 0. Otherwise, I'm going to add 1 to the rear. 0, 3, 0, 4. Oh my. D, E. And now what?
DQ would move front up 1 and leave
Yeah.
the rear alone.
Yeah, so when I DQ something, I move it up 1. Do we really need to eliminate that A? Not that anyone would ever see it. It's still stored in that location in memory. But if I had some sort of display function, I would want to display from 1 to 4. Okay. And my count, whatever my count, I don't even know if that's relevant at this point or not, if we need it to be. So I just took out the A. What if all of a sudden we had a mad rush? I mean, this is Black Friday 20 years ago, and people were filling up this line, and here comes F, and here comes G, and here comes H. This is our downfall. We didn't make the store big enough for people to get in line. Huh. That's the problem with the array, right? Not having enough size. But have I used all of my size? No. Where would you like to put I?
Back at 0.
Yeah, yeah, we can do a little bit of a wraparound. Because what's important is these numbers. So right now front is at 1, and I'd have a count. I just made it 8. And when I put in I, all of a sudden I have 1 and 0 and a count of 8. Oh boy. Yeah. What if I deleted B and deleted C? Do I need to use modulus in here? I'm starting to go, well, size is 8 and remainder and I might. But right now, all I'm trying to do is understand the problem. This is all of my draw the picture. Draw the picture. Now I could start writing some code. But I needed to do all this stuff first before I write the code. So far, so good? Yeah, I like it. I love it. Oh, sorry. I get excited. Uh-oh. Linked list. Linked list. That's what I'm going to put you in some groups. Let you talk through linked list for a queue, just like we did a moment ago. I'm going to go back and I'm going to make some final notes. I'm going to delete from the front, and I'm going to enter in the rear. Ah, they're opposites this time. Delete from the front, enter from the rear. You are gonna now do your, let's see what you got. Scribble it down somehow. I don't know how you want to do that. You're coming up with creative ways to do this, but try to make some notes or draw a picture. Somebody could even do, I don't know if you have a movable camera like my dot cam. You might be able to take one of your cameras and draw it on a piece of paper, and when we get back to a group, hold it in front of the camera again, kind of deal. But how would this work as a linked list? Any questions? What I want you to try to do for
We
Is there
group?
just doing
something else
pseudo.
written at the bottom of the page?
Yeah, you don't need to see that yet.
Okay, all right. Just check.
It's a secret. It's Wednesday secret. Talk like a pirate day. Arg.
We're just doing pseudocode, right?
You're just doing drawing the picture right now.
Okay.
Yeah, remember over here, all we did was went as far as draw the picture. You are going to draw the picture. Make sure you got this. Okay. Okay, so here we go. Nice and easy. You figured NQ, we put A there. Whoop, whoop. Now when I get ready to NQB, I'm going to put it in the front or in the rear.
In the front.
In the front, you want to add it to the front. Okay. So all four groups, do you all agree adding it to the front?
Yeah.
Nicholas and
Right.
Andrew are shaking their head no. Okay. Andrew or Nicholas, one of you would say put it in the rear, and she's holding a picture up. Nice, nice handwriting looks good of why to put it in a rear. So let's debate it. Now, before we move on, just like I said, the last thing we want to do is have to shift with arrays. Note of the day, no shifting with arrays. Okay. My choice over here is always make the note of temp pointers. Do I need a temp pointer? Do I need a front pointer? Do I need a back pointer? Because in a way, we were using the same kind of concept over here with the arrays. And we have two thoughts in play here, and maybe they're both right. Maybe they're both right. Okay. Again, we're doing FIFO. FIFO, the first one in is the first one out. So when I get down here, I'm going to have to DQ. And somebody who said front, tell me why. Tell me why.
So with our group and group two, we thought putting it in the front and keeping a counter of how many items are in the list. What that does is then when you go to traverse and delete a node, you know that you can go to whatever your rear counter is -1 and set that pointer to null, so it'll be empty after that, and you can effectively pop the last node off and use that, and that way it's just gone and your head doesn't ever change. It's just the rear.
Okay. All of big data. I have 64,000 items. Do I want to traverse through a linked list of 64,000 items? Yeah. So again, it's that just like shifting. So again, it was basically two choices. I either do the beginning or the end. And what if I had a temp pointer pointing to A instead of a count? I could then get rid of it, but I can't get back to the node before it. And again, we mentioned something before about a doubly linked list. That would be a help to get back. But the bad part there is I'd have twice the number of pointers that I don't think I want to have. If I can keep, remember, we're going for efficient coding. A couple weeks, we're going to talk about big O notation and bring that into play. And all of a sudden, it's going to go, oh, yeah, efficiency wise. So here was in the front and delete from the rear, which we said it's going to be opposites, but I don't know that that's going to work because of moving, traversing through that whole list. What if I do this? Front points to A, and this now points to B. So I'm adding at the end. Would I still have to traverse through? If I want to add C, I add C to the end. Okay. So what's the first? Okay. Oh, go ahead, Nicholas. Mr. Rodriguez, do you want to go from here?
I try. So then you would just set front to B, A would pop off.
So dequeuing is as simple as maybe making a temp pointer to point to A. Front now gets the value of front's next. So in my dequeue, I think we just said temp pointer goes to where front is. Okay. So temp pointer is going to go to where front is. Front is going to get the value of front's next. The value I want to return is going to be assigned from temp pointers value, and then I could destroy temp pointer.
Could you explain the front arrow front, like next
Yep.
line, like the second line?
So front points to here. I'm going to make a temporary pointer that goes to this node. Now I'm going to move front over to here. So this is dequeuing. Now I did this for a reason. Now I can go get the value A and return it when I dequeue it. And then I can go get the value when I dequeue it. And then I can delete temp pointer, get rid of this node and free up the memory.
Oh, I see. Okay.
Okay. That might make it a little bit better. Or dequeuing's pretty good. Now, what if I wanted to front points to B? I have C. What if I want to NQD? So this was good. I like that. But if I want it, how do I get D on there?
You have a rear pointer point to the last node in your list.
Sure. The rear pointer is going to point to the end. So when I want to add a new node, if I want to add a new node, here's my new node. That points to this guy, which is D. Again, I have to draw the pictures. My blah, 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 blah. My rear pointers next would get the value of new node. So that's this guy right here. My rear pointer's value gets and points to new node. Well, this is already set to null. Holy cow, that might be it.
You have to move rear pointer to make sure it points to new node.
Well, yeah, I think that's what I said. Rear pointers, oh, 2 steps. Okay, so she's saying rear pointers You tell me this time what to write.
So rear pointers next
Yeah.
points to new node, but then after that, rear pointer points to new node. So the rear pointer is now at the end of the linked list.
Very good. Now, is that all that's going to be in NQ? Where might there become work? What do I have to always keep in mind? Is empty. If it's empty, what do I do? Well, front gets the value of new node, rear pointer gets the value of new node. So I might have a couple of things in there first, dealing with if it's empty. Cool beans?
Isn't checking if it's empty in this kind of easy because you're just trying to see if front and rear are both just null?
Yep. But we just have that thought process every time of the is empty. You're going to say if front equals null, then it's empty kind of deal. And if it is, front gets the value of new node, rear pointer gets the value of new node. Front gets set to new node, rear pointer equals new node.
Since we're constantly moving front whenever we DQ, don't we
Yeah.
only have to check front for is empty and not rear?
Right, that's correct. But
Okay.
we have to set rear to what's now going to be the end of. So if there's only one item, rear is here. But if there's more, then rear is going to keep rearing its ugly head. Sorry. Yeah, but cool. In D2L, I gave you something called addition. Problem.cpp, addition problem.h, figure 8.1, Q and Q.cpp. I have those pulled up on my screen. Thinking through, is this program working with an array or is it working with a linked list? Well, we'd have to know what Q was because my NQ and DQ should be written for both of them. I'm going to take a look at Q.H. Q.H. As soon as I saw line 22, I knew that I'm working with the array. Because otherwise, I don't need capacity with the linked list, but I'm working with the array. We have Q, a constructor. We have an is empty. It's just called empty. NQ display. There's DQ. Couple of things going on. My front, my back, 90 and 91. Q.cpp. Well, we got some stuff going on here. All right. Oh, check out line 41. I bet that has something to do with that wraparound. Remember we were saying mod, and if we have to move it around to the next spot at some point? Yeah. Yeah. So if I go back to, let's take a look at addition problem. That doesn't help me much. See what this program does. A random drill and practice addition problem. Problems that are answered incorrectly are queued and asked again at the end. So if you get it right, it's gone. If you get it wrong, we're adding it back in. That's kind of a neat little program. And it goes through with some problems till you get them right. But that's an example of a queue. A nice working example. Again, we have our basic class for Q. In this case, it's the array version. And then we build on that class with another class. Okay, we just looked at the addition problem on D2L briefly. Now there should be two other news items on D2L. 18.7 is missing NQ and DQ. 18.9 is missing NQ. So what I want you to do for the rest of class is go get 18.7 and load it up. I don't know where you might find NQ or DQ or some notes on it. Well, that's what we kind of just did in class. So we looked at the picture. Pow. We got a bunch of code out of it. Now we want to see if those codes are actually going to work. So I'm going to put you back in your rooms. Again, there's two news items. Do 18.7 first, then do 18.9, filling in the few lines. And it's not a lot of lines of code each time, but you got to have your story straight before you start typing them in.
I don't see 18.7. I only see 18.9.
I set them both for 1 o'clock. Okay,